tool. So I'm going to open up an Excel file. How many of you are not familiar with Excel, don't really use Excel very much? Yeah, you guys, I think you guys are going to find that it's going to turn out to be a really good tool for you guys. Okay, so this is what an Excel file looks like when you open it up. I'm going to open a new one, blank one. I'm going to blow it up a bit so we can all see it. Okay, so the layout in Excel, which is called a spreadsheet. Spreadsheet comes from a word which, if you got gray hair, you remember accountants used to use spreadsheets to keep double entry bookkeeping. You know, in a column, you know, like one of these big pages, they used to bring in spreadsheets, like the green spreadsheets that accountants, ledgers that accountants used to use. But they would have columns, and in the columns they would have all the credits, all the bills they sent out, invoices, and then in another column they have all the debits and so on and so forth. At the end of every page, they would write down the total amount of money that they're owed and the total amount of money that they owe, and then they would go to the next page and put that total at the top, and then add more to it, and so on and so forth. And if on page 1 they made a mistake, when they got to page 14, when they caught that mistake, it was a disaster, you know, because everything had been based on all those other calculations. So to avoid that, they did something really nasty called double entry bookkeeping, which means that instead of going back and correcting that mistake, you made another line that was an adjustment to that credit or whatever. And you made another one that adjusted the adjustment and so on. So it was really kind of nasty. So in the mid-1970s, a couple of guys developed a piece of software called VisiCalc, first spreadsheet program. And basically what they developed was a tool that mimicked that paper spreadsheet, but it had a lot of significant advantages. Well, for starters, it laid out information just the way that a paper spreadsheet did. It had rows and columns, and each one of those cells, these little boxes that are identified by the row and column, like right now we're in C4, is called a cell. Okay, so you could locate the location of that cell. You could describe the location of that cell by just giving you the column letter and the row number. Okay, and in the beginning they were, you know, like very limited, only a couple of hundred rows and columns and so on. Now it's practically infinite, I'm sure. So within each one of these cells, you can put 3 kinds of information. Okay, Excel, in terms of what that information means, is pretty dumb. You know, it just knows that it's got one of these 3 kinds of information. One of them is called a label, which is just text. Okay, so that's a label, just text. Notice it left the lines whenever you put text in. The next thing you can put in is a number. Okay, so I'm going to put in 123, for instance. And the next thing that you can put in, notice that right aligns when it's a number. You can go in and format these things, change the font to text. With a decimal, with a number, you can change the number of decimal points that appear and so on and so forth. Interesting thing is when you format them and you round it, you take away decimal places and it rounds, it actually stores the original number. So you can actually, if you have to make further calculations on it, rounding doesn't wind up being a disadvantage in Excel because it remembers what the number really was, just displays a more convenient form of it. So you can have, so far, labels, and you can have numbers. The third thing is what really distinguishes this from a paper spreadsheet, and that is you can put in a function or, say, essentially a formula. So for instance, what I could do here is I could have a few numbers here, and then I could create a cell that has a function in it. In this case, I'm going to say that the function is the sum of 3 other cells, the ones I just drew. Okay, and I can do that 2 ways. First, I got to tell Excel that it's a function. And the way that I do that is I touch the equal sign. And you may have noticed that a couple of things changed up in this top line here where it describes that cell. Okay, that equal sign, now Excel understands that's a function. So one way that I can tell it that that's a sum of those 3 items, I can just literally just tell it, well, that is cell C3 plus cell C4 plus cell C5, and it'll add them up for me together. Okay, nice thing about this is that if you're an aeronautics engineer and you're doing wing calculations over search of wing and you did 75,000 calculations and have all sorts of data in there, if you notice an error, if you correct that error, it automatically updates all of the cells, all of the calculations that are based on that error. That's an enormous advantage. Okay, so that's really what distinguishes Excel from basically any other kind of like ledger or spreadsheet or just simple listing of numbers and so on and so forth. Now, because there's so many functions that you might want to work with on these numbers, and might want to use those functions over and over again, there's actually functions built into Excel that you can describe. So for instance, instead of adding those three numbers together that way, I can use a built-in function called, I'm going to put an equal to tell it's its function, and I'm going to type in sum. You'll notice that there's a list of functions that show up here that are spelled that same way. And now when I want to tell it that I'm going to take a sum of a set of numbers, I can put in parentheses, and I can tell it the range of numbers that I want to add together. So this time I'll say C3 colon 2, in other words, C5. And I'll get the same answer as I got there. Okay. Another thing that I can do is if I do the sum over here equals sum, another convenient thing that I can do is that anytime we do any typing, we know we have a potential for making a mistake. Anytime we transpose numbers, re-enter numbers, and so on and so forth, instead of describing where the cell is by typing in C2, I can just click on, once I get that parentheses, I can click on it and drag, and it will fill in that range of numbers for me. Then I can hit enter, and it can do the same thing for me. Well, why are we learning about this in a statistics course? We're learning about this in a statistics course is because there's 50 or so statistical functions built into into Excel. I'm getting ahead of myself there a little bit. Okay, so let's take a look at that. I'm going to open a file. On the Blackboard, under the labs, under session 1, you'll find a lot of different material, and that's those are remnants from previous semesters and extra exercises, and things that I can work with when things come up, and stuff for you to, if you really want to explore a little bit more, et cetera, et cetera. But what I did for tonight is the first entry on there, the data files that are at the top there, that first set, if you go there now on Blackboard, that first set of 4 or 5 files are stuff we're going to work with now. So if you want to download those, the best way to deal with that is to right click on them and say save as and drop them on your desktop. If you just click on them, some versions of Explorer or for instance, particularly Explorer, but some of the other browsers, they will open in the browser, so they're not really open in the program. So you want to save them to your desktop. Once they're saved to your desktop, you can actually go and open them. So I'm gonna work with the first one, and the first one is called Descriptive Statistics Exercise 1. Surprisingly enough, and I'm going to start using some of those Excel statistical functions. Okay, so for instance, we know that the mean is the arithmetic average of a list of numbers of data, numerical data. So I have a list here with numerical data. Okay, and this might be some sort of sample. It looks like it starts up there. It looks like about 18 different subjects, scores for subjects or something like that. Maybe student scores, maybe some other kind of data, maybe weights, blood pressures, or something like that. And in fact, surprisingly enough, there is a function in Excel that will count those for me. And it's called, surprisingly enough, equal count. Every time I think about that, I think about Sesame Street, So, but at any rate, not the same thing. So now I want to count how many numbers there are in that sample. So I'm going to click down. I'm going to scroll down to the last number, hit enter, and you'll notice that if I click in there, you'll see that the description of that cell is count parentheses equals count parentheses A2 to A19. Okay, and how many are there in that group? Is 18 people in that group. Okay, so now what if I want to find the arithmetic mean? Well, one way is I could actually calculate it myself, right? So I would have to take the sum of all those numbers. Okay, and I could take the sum of all those numbers. I could actually type in A2 to A19, or I could do this again. Okay, and the sum is 1799. Well, I could also, as part of that formula, divide by the count, which is 18. And I can either type in 18 there, or I can click into this box, which represents 18, and take that, and it finds the arithmetic average for me. Okay? Now, I really didn't have to even do that because there is a statistical function built into SPSS. This is a bad example of the statistical functions because the function has a different name than what we call it in statistics. It's called average. There isn't a function specifically called mean. It's actually called average. And again, I can either type in A2 colon A19, whoops, A19, close parentheses, and it'll find the same number, do the same operation for me with just that function. Okay, so now there's a number of other statistical functions. Mean, median, actually I don't have median here, I'm going to type in median. Let's give that one a try. Equals, and let's see if there's a function called median. MED, and sure enough, there is a function in Excel. So one of the ways you can explore for functions is just to type it in and see if it comes up. Click on that, it's waiting for me to tell it the range of numbers that are involved here for the median. Anybody remember what the median represents? What's the difference between the mean and the median? The mean is the arithmetic average. The median is the middle number, right? Physically the middle number. Okay, in other words, a 25th is kind of one of those means. And median is 100, right? Pretty close to the mean. That's a good thing because we're going to talk about that later. It seems like that would suggest it's a normal distribution, but we're not going to worry about that right now. So now, what about variance and standard deviations? Mean and median are measures of the central tendency, right? Where the center is. What's standard deviation and variance? They're measurements of the spread, right? So all of this stuff that you see next to here is a way that we could actually calculate mathematically, as if we had a pen and paper, except using it with Excel, how to calculate the standard deviation and the variance, where that really comes from. We're not going to do that because Excel will do that for us. I will either put up a video or do it in some other. I'm going to talk about some other ways that we're going to be able to exchange some information and do some review and stuff like that. But I'll do that separately because right now we have a lot of stuff to cover. But instead, I'm going to use the built-in functions for in Excel. So the variance, the variance is equals VAR. Sure enough, there is a function called variance, VAR. There's a lot of different forms of it, VAR.P, VAR.R. For our purposes right now, just VAR is fine. And I'm going to put in parentheses, and I'm going to put in that range of numbers. And that's the variance, and I'm going to find something called the standard deviation. Anybody know what the relationship between the variance and the standard deviation is? They're both measures of variability, of difference or change, and so on and so forth. The standard deviation is the square root of the variance, exactly. So I'm going to do it two ways here. Equals standard deviation, STDEV, I happen to remember this, right? Standard deviation, and A2 through colon A19, and that comes up to be 7.72. So I'm also going to do it another way here. Equals, there's a function for the square root, SQRT. Some of these things not immediately obvious, so you're thinking, well, what if I don't know all of these things? We'll talk about that in just 1 second. So the square root of 52.52 is 7.42. So it comes out the same way, right? Magic. You have a function for minimum, equals MIN, right? I'm not going to actually do that now. You can do that on your own. You have a function, hit escape if you get into that, maximum equals MAX. So it'll find the minimum number and the maximum number. For a list of 19 numbers, that's not just such a big accomplishment, but if you had a list of 1900 numbers, that might be something that's valuable to you to be able to do automatically. The range is the difference between the maximum number and the minimum number, the range between the two. So you're going to learn a lot more about these things called descriptive statistics next week, but we're just examining right now the fact that we have a tool that'll help us calculate these things and how it works. Percentiles. You guys know when you took the GREs, you got a score, and you also got a percentile. Within the million people that took the GREs that year, where did your score stand? If you were 76 percentile, it means 76% of the people were below you, 24% of the people scored higher than you, and so on and so forth. And there's something called interquartile range. We'll get into that next week. That's the difference between the 25th percentile and 70. It's a middle 50% range. Okay, so for how many of you is this like kind of something new? At least a bit. Okay, good. So we're not wasting our time, right? Good. All right. So before I go any further, I want to mention I generally hold voluntary review sessions most weeks, and I'm going to start out probably not this week, but next week I'll start out probably be on Thursday in the evening. And it'll probably be something like 8 or 9 o'clock or something like that for an hour or so. I do those online. I broadcast it on GoToMeeting. You can sit at any computer or an iPad or something like that. And you can actually log in and see my screen just as, in fact, right now, we're doing that right now. My screen is not actually, my computer's not actually attached here, is actually on the internet looking at GoToMeeting and seeing my desktop screen here. So you'll see the same thing when you're online and hear my voice. So I generally hold those about once a week. I'm going to start off on Thursday, but I'll be varying the times and dates so that guys that have work or have another class on Thursday night can, so we'll do it some other, might have a few Wednesdays. I try, assuming there's no technical difficulties, I try to record the sessions as I'm doing right now so that if you can't make those voluntary review sessions, but you still want to see what came up, you have an opportunity to see it as well. Okay, and there's a little chat box there so you can ask questions and stuff like that. That's assuming I don't go off on a tangent. Don't look at the chat box for half an hour or something like that. Okay, so anyway, that's what we see in Excel right now. So Excel is a valuable tool. And Excel, one of the things I was starting to talk about is that there's many, many functions built into Excel. How do I know what they are? What if I don't remember square root is SQRT? Well, if you click on this little f of x, function of x, if you remember your math, if you click on that in the formula bar, it's called a formula bar up here. If you click on that, it comes up with a listing of all of these functions. Okay, and if you look at this, right now it's showing the most recently used functions. However, you can sort these functions. You could, whoops, didn't like what I did there for some reason. Okay, you can sort these, but you can also scroll through them, and you'll find that there are engineering functions in there, financial functions in there, real estate functions, all kinds of stuff. And you can actually sort through these, and actually, if you want, there's a section where the statistical functions are listed. I don't want to click that again because it kind of crashed on me there for a second, so I don't want to do that again. But if you scroll down here, you'll eventually get to this trigonometric functions, log functions, math functions. See if I can get this, see if I can, you can see there's like many, many of them. Quartile rank, normal distribution, these are our statistical functions. They're all gathered together there. So if you go down there, go to where you can find statistical, that'll list all the statistical functions for you. So if you want to go through them and see which ones might be valuable to you, you can find it there. But we're going to use a lot of them during the semester, so they'll become pretty much second nature to you by then. Okay, so I'm going to move this out of the way, and I'm going to go to the second thing I wanted to cover, which was SPSS. Okay, so I'm going to do this from scratch, actually. I'm going to go over here, and I'm going to type in IBM SPSS student versions. Okay, and there'll be a number of things that comes up. Many of them will be from SPSS partners or from resellers of SPSS. One of them will actually be from SPSS. See, this is Hearn. This is studentdiscounts.com. This one is SPSS overview. I'm going to click on that. This is a good starting point. And when I go in here, I will find a description of SPSS Grad Pack. That's their student version of this software. The professional version of this software might be $800 and up. It's very expensive. But you can buy student versions called Grad Packs. And if you click on here, if you go into the top part of the SPSS Grad Pack page, if you click on there, buy from an IBM partner, you'll see a number of places, including ones that we have listed on Blackboard, like onthehub.com and so on and so forth, Hearn software that we just saw. Actually, and you can just check them out, see which one's the cheapest. But basically, you can go to any one of these. So you can click from there, goes to their website, and you can purchase this software. Okay, now there's going to be several different options here. The first thing that you have to make sure is that you buy the right one for your operating system. They got Windows versions, they got Mac versions. If you got a Mac, make sure you buy the Mac version. Of course, if you got a Windows version, make sure you buy the Windows version. Notice Windows and Mac operating system. Now they have a premium version of the Grad Pack, a standard version, and a base version. In this particular location, the base version is only $35. That's a really good deal. Okay, so I don't know what the others are right now. So for $35, you get a 6-month license to run SPSS on your computer. After 6 months, it's like the glass, like the glass slipper, the pumpkin, and so like the coach turns into a pumpkin. Actually, tell you the truth, what will happen is it'll tell you that you're expired, but it'll let you run for another 30 days in case you get into that. You need it for the run. You see your license expire on the last day. Don't freak out. You have a little bit of time before it really stops working. So the base version will give you 90% of what we do in this course. It used to give you 100% because we really just kind of, in the fundamentals course, we really used to just touch on the beginnings of discussion of regression. Now the attitude is regression is such an important part of data analysis that you really need to know something about it. So we will be covering regression at the end of the semester. The base set version has a simple version of regression called linear regression. The standard version includes something called logistic regression. Okay, just a little bit more flexible than just linear regression. So we will be covering that this semester. So it might be a bit more expensive, like $50 or $60 instead of 40 or $50 or something like that. It's worth doing because you'll have it then to work on your own computer. If you can't afford that and you want to go for $35, that's okay. But in those last couple of weeks when we get into logistic regression, you'll be stuck using either virtual desktop or coming in here and borrowing a laptop or going to any of the other campuses. All the other campuses have in the libraries and the computer rooms, they all have SPSS on all the machines there, right? And they have full versions of it. So I would suggest you get a standard version. And I really strongly recommend you buy one of these versions because it's just so frustrating. I've tried it myself. It's really frustrating working with virtual desktop because it drops out, you get disconnected, you got to start again. You don't know where the hell your files are stored and stuff like that because you're working on another machine. You're just a screen and a keyboard. All of the software and so on and so forth is on another machine somewhere buried in the basement of 60H, who knows where, right? So at any rate, so it really is worth doing, especially if you're not comfortable with this, because if you want to learn how to ride a bicycle, it's nice to have the bicycle rather than to maybe try and borrow it every once in a while from somebody else. And this is like riding a bicycle. You'll really learn this stuff. You'll really learn how to use SPSS by actually using it and getting used to it. And functionally, it's very good for you also because when you get to a test and you have a limited amount of time to solve problems and complete the test, the last thing you want to be doing is trying to figure out, well, where do I find this in this menu on SPSS? Or how do I do this? You don't want to waste time with that. If you're comfortable with SPSS, it'll save you time on the exam as well. Okay, so that's how you get it. The prices, you can get a 6-month license, a 12-month license, or a 24-month license. The prices gradually go up. Obviously, 12-month license is less than double, but 6-month and so on and so forth. So if you know you're going to be taking courses where this is going to be valuable to you, you might even want to go for a longer license as well. But all you need for us is the 6-month license. And again, make sure that you choose the right version. Okay, mine's a Mac, so I would choose that one. Okay, or if I went to that's the standard version. Okay, so that's how you're going to get that. What's going to happen then is it's going to send you a link for you to download the software to your computer. Large program, it'll take a little while to download. Once you get that, you'll also get an email or some other communication that has a license number built into it, and you'll have to run a licensing program to get that to work on your computer after you install it. It should have all the instructions. Most of these guys are pretty good at giving you feedback, or if you have run into problems installing it, they'll help you out a bit. IBM, I think you can even get them on the phone sometimes as well, which is kind of rare these days. But I know On the Hub has been pretty good, and I'm going to make sure that I think there is right now. There's a thread, a listing on the discussions board where you can post your experience with getting and installing the software. So if you had a good experience that these guys, you got a problem and you got good support from them, or you didn't get good support from them, you might want to post it there so the rest of us can learn from that as well. Okay, so that's SPSS. So what is SPSS? Let's go to SPSS now. Okay, let's see. Can you guys hear me in the back? Good. Okay. Am I going too fast? Am I chattering too much? No? Okay, good. All right. Okay. So there's a document on Blackboard, which is kind of like an introduction to SPSS. Professor Wyka kind of just referenced it. She showed you a couple of slides that have some of the information in there. I can't, that word for some reason takes a while for me to be able to scroll in it. But that's a document that kind of runs through some of the material I'm going to be talking about right now. But I'm going to open it up live and we're going to actually work with it. Now, there's two ways for me to open this, of course. I can either double click on the file and it'll open the application. You'll notice that I have it set up so it shows the postscript on the file name. The postscript on SPSS data files is .sav. When you do some analyses and produce graphs and tables and so on and so forth, you output them, that's going to output them as an output file. And we're going to see that has a different postscript, and there's another thing called a syntax file and so on and so forth. We're not going to worry about that right now. Right now, we're just interested in being able to identify what's an SPSS data file. So I'm going to open SPSS first. I'm going to cross my fingers and hope my license hasn't expired. It's been a while, right? It's been a month. Right? I don't get your discount, by the way. I have to pay $200 for it or something. And they don't have a version you can install on outside computers anymore. So, okay, so here we go. We've opened up. It opens up with a blank data sheet. Actually, it opened up with a little window, kind of like most programs like Word and Excel. They open up with a window where you can choose a template or open a file from there or do some other functions. You have a little checkbox down there. If you don't want to see this anymore, you can make it so it doesn't go away, and it just opens with a blank page here. So what does this look like? What have we seen in the last half hour that looks like this? Yeah, finger, it looks like Excel. It's got columns and rows, they're identified, and so on and so forth, 1, 2, 3, and 4. The real difference here is that these cells are just storage. They don't actually have any function besides storing information. The rows represent cases. They represent, for instance, subjects in a study. Could be their name, could be their weight, could be their BMI, could be their blood lead level, it could be their blood pressure, and so on and so forth. Right? Each one of these lines represents a person, right, or some other kind of a monkey or something like that, some case, right? The columns, on the other hand, represent variables. The first column could list all of the weights of all of those subjects. Second column might list all of the blood pressures and so on and so forth. So we have rows represent cases, columns represent variables, name, weight, address, city, state, so on and so forth. Okay, so I'm going to open up a file that we have on Blackboard, NC Birth 800. It's like a truncated version of all of the births in North Carolina in, I don't think, probably something like 1990 or something like that. So that file is on Blackboard. I don't want to close this. Okay, I'm going to go to File, Open, Data, just like any other program. I'm going to go to my desktop, and I'm going to look for that file. And I don't see that file. That file is actually in a folder, Lab 1. Okay, and I think it's in here. And there it is, ncbirth.sav. If that were an Excel file, a Word file, some other program, SAV, for instance, if that were an SAV file, which is another, if that were an SAS file, another program that's used for statistics, SAS. If that were an SAS file, we wouldn't see it. Because right now, it's only looking for SAV files. It's only looking for that file type. You can tell it to look for other file types. In fact, you can tell it to look for all supported data files or even all files. And you see other stuff show up. So if you're looking for a different kind of file, just keep that in mind. It's only going to show you the ones that it's targeting in that little Dropbox file type Dropbox. So I'm going to select that. I double click it or say open, and it's going to open a new data set for me. A lot of you will get this warning that, let me mention this while it's up there. Get this warning about the data formatting in Unicode or some other coding, right? Just say okay to that. What that's warning you about is that older files were coded differently, and newer files are coded with a different format. And SPSS is just warning you that if that's an issue for you, that you should be aware of that. For us, we don't have to worry about that because that change in coding took place a long time ago. And for the data files we're working with, it's not going to be an issue. I'm sorry, what were you asking?
If I wanted to import something from, let's say, Excel into SPSS.
We're going to do that, as a matter of fact. Yes. Okay. And SAS, for instance, and a lot of other things. You saw the file type there. We could actually open that file type and import it. But we'll see that we'll see that right after this. Okay. So what do I have here? Unfortunately, it's not easy for me to really zoom in on this. IBM, that's a great program, but they really haven't kept up with the interface changes very much. So I can't just go wing like that and make it blow up on the screen. It doesn't do that because IBM, I guess they can't be bothered. So at any rate, it's only $1,000 program. Why should it do that? So at any rate, so it's a little hard to see. That's why if you have it open on your computer, it's a little easier for you to follow with me. Okay. So you guys, is that okay? You guys should I wait for you guys to open it a little bit? You need a little bit of time, or can I go ahead? I can go ahead. Okay, good. All right, so what do we have here? Well, right now we're looking at a data file. And if you look, let's see, we have subject number 1, subject number 2, subject number 3. Those are the cases. Those represent births, right? And if you look at the columns, we have columns with names, variable names, plurality, sex, M age. What do you think M age is? This is birth, right? These are births. What's M age? Mother's age, right? Not very descriptive though, right? MAG, if you showed that to someone else, wouldn't make any sense. That's a problem. We're going to fix that problem very quickly. Okay, and let's see. Weeks, that's weeks of gestation. Marital status, mother's race, so on and so forth. We have all these variables that are associated. Smoking status, did the mother smoke during pregnancy, and so on and so forth. All of this information here is part of the data file, right? So each one of these rows represents a different birth. There's approximately 800 of them, hence the file name. Okay, so now there's another view of this file that we can get from SPSS. It's called a variable view. And I'm going to go down to the bottom here. You'll notice that way down here, probably not that easy for a lot of you guys to see. It says data view, it says variable view. If you can't see that, I can click on that right now, but if you can't see that, you can go up here to the top and the menu view has an opportunity to change that. So see right here, if I view down at the bottom, it says variables. It's a toggle. Right now it's in the data view. If I click that, it'll go to the variable view, just like clicking that tab on the bottom. So it takes me to another view. Now this view has 15 rows. What do you think those 15 rows represent? They represent the different 15 columns. Now there's 15 rows. Each one of those represents a variable. Okay, so for instance, when I look at the variable mother's age, number 3, right? Well, one of the problems was that's not very descriptive, mother's age, right? Age, right? So if I go across here, it tells me that's the file, that's the data name, right? That's the name of that data, the variable, right? And it's M age, not very descriptive. Rules in SPSS for data names. They have to be only letters and numbers, no special characters, except I think underscore, dash, or something like that. No spaces. So it makes it a little difficult to put together something that makes sense to an outsider or something like that. And the first letter the first digit has to be a letter. Okay, there used to be a pretty tight length restriction on it, but now they can be pretty long. Okay, the second description is type. It says numeric there. Doesn't really mean that it's numeric data. It just means that it's represented as a number. We're going to see what that means in a second. The third one is width. What's the maximum width of that particular data? A lot of these things like mother's age only be 2 digits, but it says 15 there just to give it plenty of space. That probably came up by default. Decimals. Are there decimals involved? Well, if we were describing the mother's height in centimeters and fractions of centimeters, we might put or kilograms, weight for kilograms, we might put decimals in there instead. So we might have 1 or 2 decimal places. But in this case, none of these variables are using decimal places. And then there's a variable called label. And for mother's age, MH, the label is age of mother, parentheses, years. That label may have started out blank, right? When we first put this data, collected this data, that label for that variable was blank. And we said to ourselves, gee, that MH, I don't want that on my charts and my tables that I produce. I want something more descriptive. So we typed that description in. So now any place where the variable name MH would have appeared before, now this label will appear. So it'll make the charts much more readable and so on. Okay, so if I go, so that's the mother's age. Next column is values. We're not going to work, and that doesn't need any values. It's just a number. Next one is a strategy on what to do with missing values. It'll ignore them unless you tell it something else. The number of columns, the alignment, and then the next important column is measure. Measure describes the variable type. So mother's age is what? It's a numerical variable. SPSS calls a numerical variable a scalar variable, a scale. In fact, the symbol for it is a little ruler. Okay. Well, what about let's see. What about gender, sex? What kind of variable is that? Nominal. There it is, right? There's nominal is identified there. It's important that you check the variable view to make sure that this is right, because when you want to do statistical analysis, if you try and do a statistical analysis that is only appropriate for a numerical variable on a nominal variable, it may keep you from doing it or may warn you or something like that. Okay, what about, let's see, what else we got? We got nominal, so on and so forth. So you'll notice that a lot of these weeks of gestation is going to be numerical, and marital is going to be, marital is an interesting one. Marital, okay, is going to be a nominal variable, right? So what are the values that it could have? Married, unmarried, divorced, single, and so on and so forth. Well, let's see what we have in the data view. I'm going to go back to the data view, and if I look at the data view, okay, all I see is married and not married, right? Okay, well, it's really inconvenient to have to type married and unmarried for the data entry person. Among other problems, if they misspell married, computers take things very literally, right? So if they capitalize it once and not capitalize it next time, it may not recognize that as being the same thing. So very often what you will do when you enter data is, instead of identifying it by typing in the value, you'll identify it with a number, right? So now all the nominal variables change from descriptions into numbers, 1, 0, so on and so forth, right? Well, how did that magic happen? If you go up to that view again, you'll notice that there's another toggle, and that toggle allows me to show the variable labels or not, or show the numbers that represent the variable labels. So really, when the person entered this data, when they said married, they didn't put in married, they put in the number 1. And for this person, they didn't put in not married, they put in the number 2. Okay, but how do we tell SPSS what that means? Well, in the variable view, we can identify that under this column called values. Notice that for the numerical variables, it just says none, because we don't need it because the number is a number. But for the categorical variables, we have to identify that. So if I click in that cell, little box shows up. If I click that, the values show up. So 1 is, from now on, SPSS knows 1 that represents married, 2 represents not married. Okay? So if I want to add divorced to that, I would say 3, divorced, and click add. So now there's a third value there. Okay, if there was a 3 that appeared there somewhere. Okay, so that's basically how we were. I'm going to go back to the data view. And now that we see how this data is stored and arranged, we can do a lot of functions with this data. There are, if we click up at the top here, we see a column called Analyze. And we have all of the different kinds of statistical analyses that we can do. Descriptive statistic, compare means, here's our regression, so on and so forth, correlation, So there are all, that's where our access for all the different kinds of statistical calculations that we're going to do. Okay, if we want to change the data, if we want to transform the data in some way, combine it, maybe we know the weight and we know the height, and we want a new variable called BMI, we can actually create a new variable by doing a calculation on two others and create a new row by transforming it. So we can do all sorts of interesting stuff with this. I'm just going to quickly do one thing. I'm going to say analyze. I'm going to say descriptive statistics. Okay, I'm not really doing this. I just want to show you that you can do something like this, descriptive statistics. I'm just going to say, let's see, completed weeks of gestation. Okay, and I'm going to say okay, and it's going to come up with a calculation for that. It's going to calculate, that's 799 subjects. One was missing apparently. 22 years old was the maximum, 45 was the, 22 was the minimum, 45 was the maximum. An average age of 30, this is weeks, 30 to 22 weeks, 45 weeks, 38.61 weeks. The standard deviation was 2.7 weeks, and so on and so forth. Very interesting. We'll start learn how that works later on. But now, notice what's happened here. That's a different window. It's not two sides like variable view, data view. It's a completely different window. When I quit my data view, right, when I close out SPSS and save my data view, if I don't save my output, I won't have it anymore. It gets saved separately. I think it's a .spo file, SP output or something like that, right? It's another kind of data file. The other thing you can do with this, just remember to save it. The other thing you can do with this is that you can take any one of these boxes, for instance, calculations, charts, things like that. You can also produce charts in here, graphics. You can take these, you can copy them. Notice I highlighted it in this box down now. I can say copy that. I can go into a Word document and I can paste that table into my Word document. So if you're preparing a report, a thesis, some other paper or something like that, you need that in some other document, you can now take it from here and use it in that other document. You can also edit this as well. You can put it in there in a form. You can edit it if you want to edit it and so on. You can produce tables, graphs, all sorts of useful stuff. That's one of the reasons why it's so important that you be able to label it the way you want, so that these charts, instead of saying weeks, instead of saying just weeks, it put into the table completed weeks of gestation, parentheses weeks, because that was the way it was labeled. The actual variable name was weeks. Okay, so how are we doing on time? What time is it now? 7:10. Oh, we're doing pretty good on time. Okay, so that's That's basically how we get into SPSS. Okay, so let's see. Let me see what I'm going to do here. Okay, so someone asked about, well, what about if I got data in another program, right? Okay, so let's take a look at this. I have one of the data files that's on Blackboard. It's called descriptive statistics underscore exercise 1 underscore Excel to SPSS. The only difference between that and the one that we were working with before is all that other detritus is not there. It's just a list of numbers. Okay, and you'll notice that there are 18 numbers there. Same file we were working with before. I can blow it out so you can see it a little bit better. Right, same numbers we were working with before. Well, let's say I want to work with that in SPSS. Let's say I have other programs that have data. Well, you can do that as well. Okay, so first thing, SPSS doesn't like to open files that are already open in another program. So what I have to do first, I got to quit that file so it's not open. So I'm going to go back to SPSS. I'm going to say open data. Okay, and I'm going to go to look for that data. It's not in this folder. I think it's in this folder. Yeah, import data from Excel to SPSS. Oops. Let's open that folder. It's not there. I just saw it. Where the hell is it? Exactly. It's promise of file types. Only looking for SAV files, not Excel files. So I have to either change it to look for Excel files, and it shows up, or look for all files, right? Which will make it show up also. There's nothing else in that folder as it happens. So I'm going to open that. Well, the difference here is it's going to recognize that it's not an SPSS file. And when it opens it, it says a read Excel file. Whoops. Da, da, da. And it has it has a checklist there. Okay, this is a new version. It's a little bit different than the ones I was working with before. Okay, read variable name from the first row of data. A lot of times in an Excel file, you might, in that first row, put what that data stands for, age, blood pressure, or something like that. SPSS wants to know, is that first number at the top, is that a part of the data, or is that a description, a variable name for the data? Right? Well, in our case, it's not a variable. So we would not check that because it would give the variable name 99. It would give the column or the variable the name 99, not use the 99, which is actually part of the data. So I'm going to uncheck that. Okay, so I'm going to, and then from there, it just wants to know, it looks like it's got all the data read in. So I'm going to click OK. That's really probably the only thing that's going to come into be an issue for you in most of the data sets we work with. It's going to open that and crash, I suppose. Is that what it did? Open. Let me try that again. Data. Excel. No, the data came in. The data is looking different than the old version. I just updated this version. Ignore hidden rows and columns. Percentage of values that determine. I don't care about that. Range. It doesn't show the range, does it? A1 through A18. See if that makes a difference. Okay, where'd it go? There it is. It minimized it. That's why we didn't see it before. It actually opened before as well, but it was minimized up in the corner. Those are the numbers imported from Excel. I could have done that with even larger file. Oh, I got another one on here. That's not, you don't have. I'm going to open it right now. Data. See if I can't find it. You know, all the other windows on the Mac have a little window up there, search window, right there. So from the file window, you can search for any file on your Mac. Of course, IBM doesn't, they don't need to do that because they're IBM. But okay, let me search for it this way. Here we go. Okay, here's a listing of the passengers on the Titanic, and it's their names, their passenger class, their age, their gender, and whether or not they survived. Okay, I'm going to save. That's an Excel file. I'm going to say save as. I'm going to put it on the desktop. I don't want to hide the. I'm going to save it. I'll post this later on in case you guys want to play with the data. Okay, so that's an Excel file. So I'm going to open that Excel file. Open, data. And this time I'm going to go to the desktop. And I'm going to look for it. I don't see it because it's an Excel file. I'm going to do this. Whoops. Excel. And sure enough, Titanic. Where is it? There it is right there. I'm going to say open. And it's going to ask me. Now this time, read variable name from first row of data. Well, in fact, the first row of data in Excel was name, class, passenger class, age. So it was the variable name. So I'm going to click OK. So when it opens it, it puts that variable name at the top. Oops. If I can find it again. Okay, where did it go? Here it is down here. But it's kind of weird, right? So there it is. Here's the variable name at the top. Here's the passenger class. Here's the age. Here's the gender. I got a problem. The data 0, 1. I don't know which one's male, which one's female. Right? I can if I go over here, I can kind of deduce it. But the class, certainly the passenger class, I don't know what that was. I need information about what that stands for. So there's something separately that you need from this data. You need a code book. You need to know what these different codes stand for. And in fact, we have a code book for this. Oops. See if I can find it quickly. Here we go. Okay, here's our code book. What does our code book say? Okay, code book says that survived, 1 equals yes, 0 equals no. Gender, it doesn't say gender, does it? Passenger class, first, second, or third, it's probably 1, 2, or 3, right? And so on and so forth. So survived, yes or no. 1 is yes, 2 is no. So if I want to do analysis on it, and I want the survived or not survived to be properly analyzed and separated, I need to go to my variable view and tell it that for survived, the value, which is a nominal data, the value 1 represents survived, and 2 represents did not survive.
Zero.
That's 0? Yeah, thanks. Okay. Good, you're paying attention. Good news. And there you go. Okay, and in fact, if I go up here to the view, I can, right now it's value labels are toggled off. If I go down there and turn value labels on, it shows what the 1s and the 0s represents. We do the same thing for gender and so on and so forth. The others are nominal data, right? You got your name is nominal data. A class is 1, 2, and 3. So you go in there and say 1 represents first class, 2 represents second class, and so on. Then you can do analysis on this, right? We can analyze. Let's see, let's see, descriptive statistics. What can I show here? Descriptive statistics, frequencies, variables. What am I going to do here? Let's see. Oops. I don't want to play with this now. I'll kill too much time. But anyway, we can do various analyses on it at this stage. So we click now again, variable view, data view, rows, cases, each one represents a person, columns represent variables, and so on and so forth. Okay, so any questions about that? So you guys are all raring to go. You're going to go online tonight. You're going to get your credit cards out. You're going to buy SPS, right? You're going to get started with it right away, right? Because the sooner the better, really. Since you got to do it anyway, you might as well do it now when you have time to play with it.
You're not finished now, but you can do an analysis basically on
I could compare the percentage. The percentage of people in first class, second class. I can find the average age of people in the different classes. I can find and compare that, and so on and so forth. So we can do all sorts. I'm tempted to, but if I do that, I'll forget it. We'll be here all night. What time is it? I put my phone down in the bed. What's that? 7:20. Okay, good. I need to go over something else that's kind of a necessity here tonight. So even though I would love to play with this right now, but we'll get around to it. And we still have that database. I'll make sure it's posted on Blackboard so you can tinker with it if you want. Okay, so the next thing I wanted to show you was a city program. It happens that in biostatistics, because it's an entry-level course, they ask us to have you complete a certificate program, an online certificate program in ethics and human research. Okay, it's run by an organization. I don't know where the origin name is, but it's called cityprogram.org. A lot of institutions subscribe to this organization. So CUNY, for instance, subscribes to it so that you can take this training for free. It's basically about 4 to 6 hours of reading, and there are different modules. After each module, you take a short 4 or 5 question multiple choice exam. You got to score 80% overall on the whole thing. You get to go back and redo the exams. It's not like there's not any advantage there's not any disadvantage to not getting 80%. You get to go back and do it again as many times as you want to. But we want you to do that so that if you're involved in handling sensitive data, or if you're involved in research that involves surveys or psychological studies or whatever, social studies that involve human subjects, then you've been trained on ethics. in human research. And it's a necessary part of it because we have something called an internal review board. Any kind of research that gets done here has to go to the internal review board, and one of the requirements is people that are going to be involved in this study or trained in this. How many people know about the Tuskegee study? Okay, almost everybody. You're going to see that in there. That's typically going to be something that historically is significant in human research and ethics. How about anybody know about a study where a graduate student that was died from a challenge study in asthma recently in some research study? Well, we don't know about that. So there's stuff in here that you don't know about. There's another one where a patient with a genetic issue was treated with some sort of gene-altering virus or something like that. He died. I think it's in this as well. So there's a lot of current information that's going to be in there that maybe you don't know about and you should know about and learn something about handling and preserving the data. Okay, so at any rate, so how do we do that? Well, we go to cityprogram.org, and they've made their website enormously difficult to navigate compared to what it was before, because they also offer many for-pay instructional certificates. Okay, things the continuing aid credits and so on and so forth. So you kind of have to navigate your way through it. You can go to courses. If you click on that, it'll show you all the different courses. Down here, human subjects research. So I'll click on that, and then it's going to say, okay, human subjects research. It describes what this program is, and it tells you, okay, you want to go ahead and buy this program so you can go ahead and take this course. You click on buy. It will take you to, the first thing it's going to ask you is if you're associated with an organization. And the organization you're associated with is CUNY. So if you start to type in CUNY, right, you'll see that CUNY University comes up. You can click on that, and that should allow you to agree to the terms. You agree to terms of service, agree to everything they tell you to agree to, because obviously you're not, oh, I'm sorry, you don't want that one. That's an independent learner. You're not associated. Okay, and then you do, like, obviously all these things now, you can't get anywhere if you don't agree to it. So it's almost like not agreeing. I affirm that I'm an affiliate of City University. Click that, and now you can continue to the next step. Create a logon. If you've done this before, if your certificate is less than a year old, you can give us that one instead. If it's more than a year old, you should take the refresher. Reasoning there is, I think the certificates are good for like 2 years or 3 years. So if you have the refresher or a new certificate, we know that that's long enough to last through the time that you're probably going to be here. But if it's 2.5 years old and you're going to be you just started because you did it somewhere else, the refresher is much shorter, so you don't have to take all the topics over again and so on. So you would go through this, identify yourself, and so on and so forth. If at any point it asks you for a credit card, no good. You should not have to pay for this. Okay, let me know. You can post on. You can email me or post on the discussions forum that there was a problem with that. It didn't recognize you as an affiliate. I think when I went on here, it asked me to put in an employee ID number. Okay, now I have one. You don't have one. It could be it asked me for that because it recognized me from my email address as an employee. In fact, that's how IBM knows who I am. They have a listing of all the email addresses, I guess, or previous transactions, and they know that I'm not a student, right? So even though I have a School of Public Health email address. So at any rate, if it does ask you for money, let me know. We'll figure out what the issue might be, or if there's some other problem that we need to know about. Okay, so at any rate, that's what you're going to do. You want to make sure that you register for human subjects research, right? Research involving human subjects. It's likely that it'll show you different options: biomedical research, social and psychological research. Most likely for most of you, that'll be social and psychological research, and it might also identify your level of learning. So you put graduate student if you get to that point. I can't. They keep changing it. I can't keep going back because I've run out. Been doing it many years, and I've run out of email addresses that they don't know. So I don't know exactly can't tell you exactly what's going to look like for you guys, but there's also a document on Blackboard that'll kind of guide you a little bit as well. I did my best to kind of navigate it for you. But if you stick to that, CUNY, Human Subject Research, basic human subject research course, and graduate student and behavioral and social research. You should be okay with the right one. When you're done with that, you will get a certificate. I think I got a picture of it somewhere. It's on Blackboard on that document that describes how to do this. You'll be able to print out a PDF on a one-page certificate, little filigree around the outside and stuff like that, your name in the middle. You can upload that PDF file to a location on Blackboard that will be obvious to you. Okay, it'll be under, most likely under the assignments. Okay. And if you can't find it, just let me know and I'll make it more obvious. But you'll upload that to Blackboard and you'll be done with that. You really should consider doing that early because inevitably there's a handful of students that last week of the semester, we got to get the grades in and stuff like that. And they haven't done it yet, and it's a required part of the course. And they're struggling to do it when they've got other finals and projects and so on and so forth. Trust me, it's interesting reading, and it's worth doing early in the semester. Okay, so next piece of information. Okay, let's see. Now, I'm going to open up something here. Okay, city program, good. Okay, this is a document you can download from the New York City Department of Health website. It's called the Vital Statistics for New York City. Okay, you can go right on their website, just Google and just search for Vital Statistics. This one's from 2014. Probably the most recent version that's up there now is for 2017 or 2016 most likely. It takes a while to put together the statistics. Vital statistics, vital means life. So these are all life and death, mortality statistics, disease statistics, and so on and so forth. There's an interesting graph. Notice I can do this here with this, with this preview, this free piece of software allows me to do this. I keep complaining about SPSS. But at any rate, notice this. This is the mortality rate in New York City over the last over the last 200 years. Pretty interesting, right? And if you'll notice, what's been going on with the mortality rate in New York City? It's been going down, right? And you can notice that look at where these spikes are. These spikes are associated with disease outbreaks. Cholera in 1832, smallpox in 1865. Here's a spike, 1918, influenza in New York City. We're having a big outbreak right now of influenza. Hopefully it won't be anything like this, but that's something that actually showed up in the the mortality rate in New York City. In fact, there's an adjustment here. And if you look at 2011, they left out mortality from terrorist attacks because in 2001 rather, because that significantly increased the mortality rate in New York City because we had 3,000 deaths from that one event. So here's a little insert here showing you what it would look like if they include those deaths in these vital statistics. Okay, so at any rate, what's in here? Well, if you go through here, among other things, it lists the number of deaths from in different areas by geography and say leading causes of death by gender, by the leading 10 causes. For instance, in the age range 25 to 30, let's go 15 to 24 years old, the leading cause of death was assault, homicide. Second leading cause of death was accident, right? Not surprising that in that age range that would be the case. And there's many more deaths among males in that age range. Percentage or the rate is much higher for males in that age range for homicides and accidents than it is for females, as it happens. If we look at this data. But this is interesting data. You can go through here all these different age ranges, what the leading causes of death were. Okay, so we took that data, right? We took that data and we summarized it here. We actually just went through there for, I think it was not 2014, it was another year. We summarized it here for the ages 25 to 44, 45 to 64, 65 to 84, and over 85. And we found how many people within that age range were in the population. There's population data in there. And how many deaths they had within that age range during that year from cardiovascular disease. And we did it for females and we did it for males. Okay. So who's more likely to die from cardiovascular disease, males or females?
Males.
Okay, good. That's a good answer. I like that answer because actually New York City is not the right answer. But we're going to see that in a second. It's the right answer and it's not the right answer. Okay. So let's see what we have for females, female population in New York within that age range for those years. Okay, actually, I'm going to do it down here. The total population was equal to sum. I'm going to use my SPSS skills, parentheses, to add these all up. And there were 2.8 million females, and the number of fatal cardiovascular deaths were equal to the sum of these, which was 12,000. Okay, so I'm going to go over here. I'm going to do the same thing for males. The total male population was equal to, I'm so glad you gave me that answer, is equal to that total male population, and the sum of the male deaths is equal to that. Okay, let's look at the rate of mortality for those two groups. Okay, so the rate of the crude mortality rate for females is equal to, crude meaning that it's just the numbers themselves, is equal to 12,000 out of over 2.8 million. So the rate is 0.004423. That's a terrible number. That's a really hard number to work with, right? So what I'm going to do is I'm going to take that number and multiply it by 100,000. So this is really kind of a percentage, a proportion, right? So I'm going to take that number and I'm going to take this whole thing and I'm going to multiply it by 100,000. I got the right number of zeros there. Oops, I don't want the right there. Okay, so now what it's done is it's changed that number from a proportion to the number of people that died per 100,000 people. So the mortality rate for females in New York City during that year was 442 out of every 100,000 females died from cardiovascular disease. Okay, let's do the same thing for males. Equals this times, I'm going to do the 100,000 right up front this time, divided by divided by the population, which is this. Oh, is that right? F18. Yeah, I think that's right. If I'm wrong, we'll figure it out later on. Who's at greater risk of dying for heart disease here? Females. What happened? Okay, let's take a closer look at this data. Right, let's take a closer look at this data, right? Okay, how many females over 85 do we have? We have 6,000. How many males over 85 do we have? We only have 2,600, right? I mean, females tend to live longer. And as you live longer, your risk of dying from cardiovascular disease goes up much higher, right? So the problem here is not that females are really dying at a higher rate than males, but that our two populations are different, right? So we can't really look at this crude mortality rate and really draw any conclusion from it. The problem is that we're referencing two different populations, right? So now we need to compare this to the same population. So we're going to get numbers that mean something, right? So how are we going to do that? Well, first thing we're going to do is we're going to calculate for each one of these age ranges an age-specific mortality rate. In that age range, how fast are people dying from cardiovascular disease? For females, it's going to be equal to this number divided by this number. So it's going to be 0.0001, right? Okay, so now I want to do that same calculation for the next four cells. 1,000 over 920, 51 over that. One of the ways I can do that is click on that box, drag down, and go up to edit, and say fill down. And it does the same calculation for each one of those in a row. Okay, another advantage of using Excel. So these are all the age-specific death rates for those groups. Okay, so now I'm going to go over here and do the same thing for males. Equals 277 divided by this. And in fact, not only can I do that, but I can click in there and go into the corner here and drag, and it'll do the same thing. Okay, kind of a shortcut. Okay. So in other words, if I click into any one of these, you'll notice that it's F16 divided by E16. This one is F15 divided by E15. It takes the adjoining columns and marches its way down, and does a calculation for each one. Why does it do that? Because that's a common thing you do with a spreadsheet. You do calculations based upon adjacent columns. Okay, so now That's the age-specific mortality rate. So now I'm going to take these values for females, and I'm going to copy them. And then I'm going to go down here. I'm going to go down to this box, which represents the same thing, the total population, which represents population. I'm going to paste them in here under this row, edit. Now I'm going to go into paste special. And I don't want that calculation. I just want the value from there, right? I just want the number. So I'm just going to paste in the number there. Okay, I'm going to do the same thing for the male age-specific death rate. I'm going to say copy. And then I'm going to go down here, age-specific death rate for males. Paste special. I'm going to say just the values. Okay, so now that's the rate of death among males and females in that population range. So now I want to know, gee, that's the rate at which they die in that population range. Now, what if the population of males and females were equal? There were the same number of males and females in each one of those two groups when I calculated mortality rate. How would I do that? Well, instead of using the real population, I'm going to use another single population, and I'm going to apply both of these rates to. I'm going to use a common population. So what can I use as a common population? Well, you might want to pick something out that's kind of generic, that's similar to the distributions that the populations might be in. How about if we just combine the male and female so that the population that we're basing it on is just a combined population of males and females? But we're going to apply both those rates to the same population, right? So it's as if there were the same number of males and females at each one of these different age groups, instead of being so different for males and females. So many more older females than there were males. Okay, so let's work out now. How many deaths would we expect among females in this category in 24 to 48? It's going to be equal to the population times the rate of death. Anybody doing this with me, by the way? Some of you guys? Okay, at least one person doing it with me. That's okay, too. Okay, hopefully you'll do this at home, too. In fact, there's a second data file that we have on Blackboard that has a similar kind of calculations. It compares cancer deaths in Alaska and in Florida to see which state has a higher rate of cancer deaths. Okay, so I'm going to click down here, and I'm going to drag this down. So I get the total number. Oops, I missed. There we go. Those are the expected number of deaths in each one of those different groups based on that rate. And then I'm going to do the same thing for males. Equals this times this. Okay, and I'm going to click here and drag it down. Okay, now I'm going to add up how many male deaths, how many did I make some? Did I do something wrong there? Oh, what did I do there? D26 times E26. That's right. Oh no, something's wrong there. B? Oh, right, the population, excuse me. You're absolutely right. Okay, let's try that again. I hope I got the other one right.
Yeah, yeah.
Okay, good. Let's add up the number of expected deaths among females, given that they're two equal populations now. Equally, same distribution to population. So we would expect during that year to have, oops, didn't like that. 19,000, that doesn't sound right to me, but I'm going to go with it anyway. Equals sum. I'm going to go with this just, and then worry about whether I have it right in a second. Third row is wrong?
Third row down.
Okay, B28. How did I get that wrong? You get the others right. Maybe it's a percentage that's wrong. Yeah, it seems like there's something wrong there, right? B28 times, it is B28. times,
It's C, right? Yeah.
that's right, B28 times C28, the population times the age-specific death rate, 0.01. Yeah, the answer does look a little wrong. 0.001, 283, B26 times C26. Well, let me go ahead. Yeah, it's right. I think it's right. Okay, so what's the crude mortality rate for females? Equals the number of expected deaths over the total population. If people are dying at the rate for that females are, I'm going to multiply that by 100,000. Yeah, it's going to come out right. Yep. Times. Okay, so the mortality rate for females, if everybody in this population were dying at the rate the females do, they would have the mortality rate would be 371 per 100,000 people. Well, what if they're dying at the rate that males are? Well, that's going to be equal to 26,000 people times 1,000, 100,000, divided by the population. And the mortality rate there is going to be 511. So what happened now? When we even up the populations, look at the rates, even up the populations, we see that males have a higher risk of cardiovascular disease when these numbers are applied to the same population distribution in terms of age. What is this called? This is called age adjustment. It's got its own special name. The general name for this is data standardization. Because a lot of times we look at data, like if we looked at cancer rates in Florida and compared them to cancer rates in Alaska, what's the problem there? What's the average age of people in Alaska? Right? If you're 60 years old in Alaska, you don't want to be there anymore, right? It's kind of a bad place for old people, right? If you're in Florida, that's a great place for old people, right? So there's a lot more old people in Florida. The cancer rate's much higher in Florida. Doesn't mean that there's something in the environment that's causing it. Doesn't mean that there's some genetic issue, ethnic issue, or anything like that. It just means that they're different populations. But now, what if we need to compare them because we want to know if there's really a difference, if there's some environmental problem? Well, now we have to account for that difference in the population, in that data, and we call that data standardization. Okay, so when we look at this, we give it a special name because so often age is an issue here, right? So often age might be a problem here when we try and compare data. We call that kind of data standardization age standardization. And these numbers are the age-adjusted mortality rates. The first numbers were the crude mortality rates. Where else might that come up? Anybody been to Paris, anywhere in France recently? What do you see on the street all over the place that you don't see in New York anymore? Cigarettes, they're still smoking like chimneys over there, right? We're down to what, 10 or 15% or something like that. They're still smoking like chimneys over there. If I wanted to compare lung cancer rates in Paris and in New York, or if I want to compare some other kind of disease or something like that, now some other cancer, right? Or if I wanted to exclude smoking as the one to look at other factors for cancer in the United States versus in France. Well, gee, I'd have to account for the fact that smoking rates are so much greater there than they are here, right? So I would have to find some way to adjust that data. We're going to be working later on this semester with a New York City community health survey. They sample 8,000 people. They get people to answer like these 200 answer questionnaires on the phone. I don't know what they do. They hold a gun to their head. I don't know who would do that. But they get them to answer all these questions about their health. What would they eat? What their diet? Have they ever been diagnosed with asthma? Have they ever been diagnosed with diabetes? Have you suffered from depression? Have you been diagnosed with this? They get 8,000 people every year to answer these questions for them. Randomly selected people from around the 5 boroughs. And every year they analyze this data, right? Problem is that they're calling people on the phone. And sometimes the response in Brooklyn might be better than the response in Queens, right? So what happens? What do you do if now you want to analyze this data and you want to get some sort of feel for what the overall rate of diabetes is in New York City? but you have many more people in Queens that responded than in Brooklyn responded. We have to weight that data. You know what the populations are relative to those two counties, right? So you might want to weight that data to correct for oversampling here versus here. So there's a lot of applications for this. And when you look at that community health survey, you'll notice if you go online and if you Google New York City Community Health Survey, you'll notice that a lot of the data is available for you to examine the raw data and the standardized data, data that's been corrected for all of these variables in the sampling that they ran into. So that's one of the things that you might want to run into. Does it make sense to you guys get this? It's a good exercise. There's data for Alaska and Florida for cancer rates. And maybe that's a good opportunity for you guys to open up Excel, to play around with the data and so on and so forth. Any questions? Yes.
Will SPSS do this for you, or is this something you have to figure out?
That's a good question. Let's get to that later in the semester. SPSS will do a lot of things for you. Not necessarily everything, but yeah, we may not get to doing standardization on SPSS. There's a lot of functions within SPSS we might not get to this at this point, or may not be available within the versions that we're using. But as we go on in the semester, that'll come up again, at a point where we can spend a little bit of time on it. Right now we have about a minute and a half. Anything else? Gotta be more questions, no? Yes?
Will you review this on the Thursday session?
Yeah, we're not gonna do a Thursday session this week, but the following week, yes. And barring technical difficulties, I just recorded all this, right? So I will convert this, put it on YouTube, and you guys will be able to watch it again. Okay. Yes? That's a good question. I saw that also. What I would do is go a little bit deeper and see what versions of the operating system will work with. In other words, version 15 may not work with High Sierra or Low Sierra or what's the name of that mountain in Yellowstone? Yosemite or whatever version they're up to now, Yosemite. Okay, so I would check that. I mean, it might be a little safer to do 24. There's not any difference in the versions that's going to impact what we do in this class. Might be a bit safer to do 24 rather than 25, just because you won't run into issues with it. And that's, trust me, IBM, like I said, they're not very responsive. This is what you call, not a lot of people buy SPSS. Excel, they sell a bazillion copies a year. SPSS, they might sell 10,000 copies a year. So they're not as responsive to updates, operating system changes. It takes longer for them to get around to it. And they're not as responsive to interface issues like, the problems that I have with trying to display it. Okay, good night, guys.